Okay, good afternoon, everyone. No look now, Thursday na naman, so we're almost on the weekend. Pero before going there, alam ko hindi kayo masyadong excited sa weekend kasi we'll have problem set number one, which will be due on Wednesday next week. Pero it will come live tomorrow sa Canvas natin, so right around 8 a.m. So if you're on our Canvas homepage, punta lang kayo dun sa either, pwede kayo pumunta sa modules. Okay? So click nyo yung modules, punta kayo sa module 4 about major theorems involving sequences. You will see here at the bottom a file problem set 1. So you can click on it. Nakalock pa siya, pero tomorrow at 8 a.m., you can download the file here. Nandun yung 5 problems that you can work on. Actually, technically, hindi 5 problems, pero 5 numbered problems kasi yung iba merong sub-questions. So, but remember the instruction is for you to just pick 4 out of the 5 numbered problems. So, merong problem 1, 2 hanggang 5. Pili lang kayo ng 4. Tapos, kung ano man yung 4 na mapili nyo, kailangan yung i-upload dito sa bawat problem set bin. So, for instance, if you chose problems 1, 2, 4, and 5, you need to upload your answers to these numbered problems individually to PS 1.1, PS 1.2, PS 1.4, and PS 1.5 respectively. Walang bonus points kapag sinagutan nyo yung pang-5. So pili lang talaga kayo ng 4. Pag nag-submit kayo ng pang-5, automatically i-ignore ko lang yung submission nyo na yon. So you can try it on your free time, on your leisure time. Baka lumabas siya sa finals or something. Pero 4 lang talaga yung i-accept ko na submissions, okay? So problem set 1 would be over 40 points. So you can check it out tomorrow at 8 a.m. And the submission will close on October 20th at 5 p.m. So make sure all your solutions are in before 5 p.m. on October 20th. Now, if you finish early one of these problems, upload nyo na siya kagad para ma-checkan ko na rin siya kagad, okay? So please take some time to think about the problems. Siguraduhin you gave your all before submitting your solutions, because problem sets are worth, tingnan ko lang sa syllabus, ang problem sets natin ay, each problem set is worth 20%. So malaking chunk siya ng grade, 1/5 ng grade nyo ay magagaling sa problem set. So you can think of each of the items to be about, or to be worth 5% of your final grade. So make sure you do your best on the problem sets, okay? Now, what else? Siguro yun lang. Or aside from going to the modules, pwedeng punta kayo sa assignments. Kaya lang sa assignments ay hindi nyo yata makikita yung problem set file. So submission lang to. So punta talaga pala kayo sa modules. Tapos look at module 4, the file problem set 1, nandiyan yung 5 tanong. All right? So you pick one. And then tingnan natin yung schedule natin. Hold on. Okay, problem set will be due on the 20th. Tapos feeling ko matatapos natin yung unit 2 by next week. So probably by the 21st we're done with unit 2, meaning time na naman para sa isang problem set. So okay lang ba kung mag-set tayo ng problem set number 2 on the 28th? Para bago mag-reading break, wala na kayong, tapos na tayo ng problem set 2. So probably October 28, yung magiging live on Canvas. Tapos, kailan ang start ng reading break? Nakalimutan kong i-check. Officially, ang start ng reading break ay November 2 nga ba? If I'm not mistaken, it should be November 2 kasi holiday yung November 1. So siguro pwede tayong October 28 to November 1. Or kung gusto nyo ay October 27 hanggang November 1. November 1 yung submission. Still 5 problems. Siguro 4 out of 5 ulit. So 1, 2, 3, 4, 5, 6. So you have 6 days again to answer 4 problems. Okay lang ba yun? Though kakainin niya yung weekends, Halloween weekend, and then also November 1, which is a holiday. Pero I think that's the best kesa may isipin pa kayo pagpasok natin ng reading break. What do you think, guys? Wala bang violent reactions doon? Sure. How about conflict with other subjects? Marami ba kayong requirements before the reading break starts? Wala? Wala kayong reklamo doon? Okay, so that would be my working schedule. So let's target problem set 2 to be on the 27th until November 1st. Ang coverage niya ay buong Unit 2. Tapos siguro magbibigay pa ako ng isang homework para sa Unit 2. Bigay ko siguro, pwede ko na siyang ibigay sa Monday, tapos ang deadline niya ay sa 25. So here's how our schedule will look like. On the 15th, lalabas yung problem set 1. Ang deadline ay sa October 20. Then sa October 18, lalabas yung homework 4. Deadline siya sa October 25. And then problem set 2 will be on the 27th. Ang deadline ay November 1. Yung homework 4 ay isang question lang. So you can work for it 1 week. So 18 to the 25th. Pero isang problem lang. Kasi alam ko baka nagagawa pa kayo ng problem set ng 18, 19, and 20. So just to give you a little bit more time to finish homework 4, isa lang yung problem na ilalagay ko. And that will be a good review for the problem set which will be live on the 27th. Okay lang ba yun, guys? Panahon nyo na para umapila. Okay. So mukhang may thumbs up naman ako doon. So, all right. So that would be our working schedule. Hopefully hindi siya masyadong mabigat. Pero sabi niyo naman ay wala naman kayong mga reactions. So I'll take it as it is okay. So yun. Madali akong kausap before mag-set ng deadline. Pero pag nakapag-set na ako ng deadline or nakapag-agree na tayo ng deadline, medyo pahirapan bago niyo ako mapapayag unless there are really some emergencies or unavoidable circumstances. Kaya sana beforehand, be part of the decision-making process. Okay? Kasi hanggang doon lang yung mabibigay kong leniency sa inyo. Hindi ko na mapapromise na lenient pa rin ako and as considerate once na set na natin yung schedules. Alright? Okay. So gusto ko lang habol yung homework 4 para tig-dalawang homework yung Unit 1 and Unit 2 para hindi naman ganun ka lopsided in favor of Unit 1. Okay? All right. So if there are no other comments about our schedule, then I would like to start our discussion by this nice quotation from Hardy. He said that a mathematician, like a painter or a poet, is a maker of patterns. And if his patterns are more permanent than theirs, it is because they are made with ideas. So, kaya siguro makikita nyo, konti lang yung mga examples na nakikita natin ngayong nag-aaral na tayo ng theoretical math. Because we are not just after specific case. We want to extrapolate the different patterns out of these specific examples. And the reason why is that these patterns are more permanent than specific cases. So we are weaving together ideas to form a coherent theory, and this theory proves to be sort of permanent. Kasi ito na yung calculus na inaral ni Newton, inimbento ni Newton, ni Leibniz in the 1600s nga ba o 1800s. Basta nung mga panahon na yon. And they are still what we are using today. So they are immortalized in their works because really in math we only accept something to be true if it is proven to be true, notwithstanding any test of fallacious reasoning or anything else, right? So permanent na siya, kaya nakikita natin, tinitingnan talaga natin yung mga patterns regarding these objects of our discussion. Okay. Now, icebreaker lang siya supposedly, pero today we'll talk about some major results, okay? So last time, tinignan lang natin yung divergence criterion at saka yung ibig sabihin kapag ang limit ng isang function, limit ng isang sequence ay positive infinity. Now we will start talking about the big theorems in real analysis involving sequences. And they are said to be big or major theorems because they are equivalent to the completeness axioms. To the completeness axiom. Though may dalawang version na tayo ng completeness axiom. We've seen Dedekind's completeness and we have seen the LUB property. Okay. Now, sabi natin dati equivalent yung dalawa. Meaning, if we will assume any of them as the axiom, we can prove the other one, and we will get the same calculus theory as we have today. Kasi ang isang mathematical discourse ay nakadepende siya dun sa list of axioms that you declared as the foundation of your mathematics, right? Dahil equivalent ang Dedekind's completeness at saka ang LUB property, it doesn't matter which one will we accept as our axiom. Parehas pa rin yung theory na ma-generate natin because we can prove one in terms of the other and vice versa. Hindi nga lang natin sila pwedeng pagsabayin kasi dapat sa isang axiomatic system, yung axioms dapat ay independent. Okay? So kaya isa lang. At ang pinili natin, I guess, we said na nagsettle na tayo sa LUB property to be our default completeness axiom. But Dedekind's completeness can be proven using the LUB property. Okay? Pero baliktad yata yung ginawa natin last time, no? Pinrove natin yung LUB property gamit yung Dedekind's completeness, which is half of the proof of their equivalence. Now we look at some theorems involving sequences na equivalent sa completeness axiom, be it Dedekind's or be it LUB property. So ibig sabihin, pwedeng wala muna tayong dineclare na completeness axiom, dinevelop natin yung idea about sequences, and then these big theorems in sequences can be regarded as an axiom from which we can deduce or prove the Dedekind's completeness theorem or the LUB property. And we will come up with the same calculus as what we studied in Math 36. Ganon ka-importante itong mga theorems na to. Okay? So let's look at them. I think we have 4 or 5 of them. My target is to talk about 2 or 3 of them today and the others next week. So we'll begin with talking about the Monotone Convergence Theorem or MCT. But before going to the theorem, kailangan natin yung idea, ano ba yung pagiging monotonic? O kailan nagiging monotone ang isang sequence, all right? And that's in definition 7. So we say, we start with defining what an increasing sequence is, but this is basically the same notion of increasing that we know before. Increasing ang isang sequence kapag ang an ay mas maliit or equal sa a sub n plus 1 for all n in n. In summary, a sequence is increasing if as the subscript increases, lumalaki rin yung value nung enter. Pag palaki ng palaki yung subscript, palaki ng palaki yung value niya. Or as you go further and further into the list, palaki ng palaki yung values. An example of an increasing sequence is the sequence consisting of n's. Because if you will list down its elements, it's going to be 1, 2, 3, 4, 5, and so on. As we go further and further into the list, palaki ng palaki yung values. All right? Ibig sabihin, pag nasa kaliwa ka ng lista, pag nasa bandang kaliwa ka ng listahan, mas maliit ka dun sa mga nasa bandang kanan. All right? And then, similarly, we say that the sequence is decreasing if a sub n is if a sub n is larger than or equal to a sub n plus 1. Doon siya nagiging decreasing. Pag habang lumalayo ka sa listahan, paliit ng paliit yung values, decreasing siya. Okay? Now, if you want to qualify, take note, pag sinabing increasing, pwedeng maging equal. So pwedeng magkaroon ng dalawang magkasunod na elements na equal sa isa't isa. And it doesn't matter because the definition of being increasing or decreasing allows equality. Now, we can further qualify this by saying that a sequence is strictly increasing. We say a sequence is strictly increasing if a sub n is less than a sub n plus 1. So dito hindi na natin ina-allow yung equality, right? And similarly, the same thing happens if we want our sequence to be strictly decreasing. So we use the relation greater than. Okay? Now, hindi masyadong nagma-matter ang pagiging strictly decreasing or strictly increasing ng isang sequence. Meron lang mga special cases kung kailan sila importante. Pero most of the times, we'll just be dealing with increasing or decreasing sequences. So going by these definitions, we can say that the constant sequence, for instance, sequence of all ones, yan ay parehas increasing at saka decreasing at the same time, right? Because the nth element is smaller than or equal to the n plus 1 element. And the nth element is greater than or equal to the n plus 1 element. So yung constant sequence, sila ay mga increasing at decreasing at the same time. All right? If we go strictly with this definition. Okay. Now, increasing din, halimbawa itong sequence na to, 1, 1, 1, 2, 2, 3, 3, 3, 4, 4, 4, 4, and so on. Increasing pa rin itong sequence na to. Kasi pag pumupunta ka sa kanan, hindi lumiliit yung values. So pag sinabi nating increasing, para siyang non-decreasing. Hindi dapat bumababa yung values nung susunod. Okay? Now, we have seen an example wherein a sequence is both increasing and decreasing at the same time. Pwede rin namang hindi siya increasing at hindi rin siya decreasing at the same time. So pwedeng meron kang sequence 1, negative 1. Medyo favorite na natin tong alternating sequence na to. Oops. Negative 1 and so on. Dahil walang specific behavior yung terms ng sequence. Minsan tumataas, minsan bumababa. So nag-o-oscillate yung value nung terms dun sa sequence. Mataas, mababa, and so on. So hindi siya decreasing, hindi rin siya increasing. All right? So medyo merong mga gray areas with respect to increasing or decreasing. Okay? But our concern here mostly would be for those sequences that are either increasing or decreasing. And the generic term for those sequences are monotonic sequences. Or we say they are monotonic if either the sequence A sub n is increasing or decreasing. Okay? Ibig sabihin nung kaya mono siya, isa lang yung behavior niya. Either increasing lang siya palagi or decreasing lang siya palagi. Kaya monotonic yung pangalan. Now, I think we're ready for the first major theorem, and this is the monotone convergence theorem. And this will answer the question we posted earlier. Because remember, meron tayong theorem before that we said that every convergent sequence is bounded. We even translated that into a divergence criterion that a sequence that is not bounded will never be convergent. Correct? So ang tanong natin dati, ano kaya yung pwede nating idagdag sa pagiging bounded para mag-guarantee na magkakaroon ng limit o para maging convergent yung sequence? And the answer lies in the monotone convergence theorem. Kasi sabi ng monotone convergence theorem or MCT for short, if a sequence is a monotone, I think the proper term here is monotonic. If the sequence is monotonic and bounded, then it is convergent. So sufficient pala na idagdag lang natin yung monotonicity para mag-guarantee na convergent yung isang bounded sequence. So and that is lacking in this example. Sabi natin bounded itong sequence na to, pero alam natin divergent siya. So kaya pala hindi siya, kung naging monotonic sana to, convergent na sana siya, right? Because adding monotonicity is sufficient to guarantee convergence, right? And so let's try to prove MCT. And as I've mentioned, MCT is an equivalent form of the completeness axiom. So you can expect that in the proof, I'm going to use the LUB property, which we elected as our completeness axiom. Okay. So let's try to write the proof. Probably I'll write the proof for half of MCT. Kasi ang assumption niya, yung sequence ay bounded at saka monotonic. Pero para maging monotonic siya, may dalawang possibilities. It's either the sequence is increasing or it is decreasing. I'll do the proof for increasing sequences, and I guess from there you can deduce the pattern and write the proof for decreasing. Okay, you'll just need to make the appropriate adjustments, but the idea and the flow would be the same. Okay, let's write the proof. Let's try to write the proof. So we let AN be a bounded sequence. Or siguro dagdag ko na yung monotonic sequence. Okay. And then I'll do case 1. A sub n is increasing. Kasi magiging iba yung proof kapag si A yan ay decreasing. Pag monotonic, it's either increasing or decreasing. So we need to divide the proof into 2 parts. Okay. Now, what do we know? Gusto kong ipakita na si AN ay convergent. Ang alam ko lang siya ay bounded at saka monotonic. Okay? So, by definition of boundedness, we can say that siguro ilagay lang natin dito yung mga alam natin. Then, there exists a real number m such that a sub n is greater than or equal to, a sub m is less than or equal to m for all n in n. Kasi nga siya ay bounded, so dapat may mahanap tayo na, actually may absolute value pala to, right? So ibig sabihin, bounded yung absolute value ni an by a real number m. And we can say that this real number m is positive, right? Definition ng boundedness. Or in other words, that is a sub n is always less than or equal to m for all n in n. Okay? So bounded siya. Now, kung bounded siya, by the LUB property, anong sinasabi ng LUB property? Does anyone remember? Bonus points, sige. What can we say from the LUB property? Anyone? Pwede kayo mag-raise ng hand. Tandaan niyo pa ba yung LUB property? Oh yes, Dan Kennedy.
Hello po, sir. Reading po ako.
Yes, go ahead.
Kapag sinasabi po ng LUB property is that kapag po for any non-empty set, kapag daw po meron siyang upper bound, may nag-exist daw po na least upper bound.
Okay, great. Thank you, Dan Kennedy. Yes, that's right. Sabi ng LUB property, any bounded or any non-empty subset of R that is bounded above will have a least upper bound, right? So therefore, this means that there exists a real number A such that A is equal to the supremum of the ANs, right? So meron siyang LUB, meron siyang least upper bound. At ang tawag natin doon ay yung supremum, right? So kunwari si A yung supremum. Now my claim is that A sub n converges to the supremum A. At yun yung gusto kong ipakita dito. Okay? Now, ito yung gusto ko nang ipakita. Ano pa yung hindi ko nagagamit? Hindi ko pa nagagamit yung pagiging increasing ng function, ng sequence. So, ibig sabihin, posibleng doon manggaling yung argument ko para mapakita na si A sub n approaches A. Okay? Nagamit ko na kasi yung boundedness, so less likely ko na siyang magagamit later. So sa ibang groups, posible naman yung isang premise multiple times yung gamitin. Pero mag-focus ako sa paggamit ng pagiging increasing niya. Okay? Now, okay. Now, by property of suprema or of the supremum, Kasi unique nga lang palang supremum ng isang sequence. Base sa mga properties ng supremum, given any epsilon greater than 0, okay, there exists a capital N in N. Tapos nakikita nyo na parang sinusulat ko na to ng definition ng convergence, right? Pero dadaan muna ako dun sa property ng suprema, ng mga suprema. Anong property nila? Kapag ka nagbawas ka sa kanya ng kahit konti, hindi na siya magiging upper bound. Kaya ang tawag sa kanya least upper bound. Pag nagbawas ka sa kanya ng kahit maliit na value, hindi na siya magiging upper bound. Yun yung property ng least upper bounds, right? So that means there exists an element of the list, let's call it A sub capital N, that will be larger than yung supremum minus a small real number. Okay? Lagi itong mangyayari. Kapag ka-sure ka na si A yung supremum, bawasan mo lang siya ng katiting, may mahanap ka na ng element ng sequence na mas malaki dun sa A minus epsilon. Alright? And then, what can we say now? Probably here I can say this is equivalent to what? A being less than A sub N plus epsilon. Or we can say this is A minus A sub N less than epsilon. All right, is it good so far? Oh, by the way, and also it will follow that A, what can we say about A minus AN and A minus A sub N whenever N is greater than or equal to big N? Ano yung pwedeng relation between A minus A sub little n at saka A minus capital N kapag ka yung little n ay mas malaki na sa big N? Ano yung relation dito at bakit? Volunteers? Oh yes, Carlo?
Sir, since mas malaki yung A sub N, mas maliit siya, mas maliit yung first term kaysa second term, or equal, less than or equal.
Okay. So you're saying alin pa lang A sub N? So ano yung mas malaki?
Yung left side is mas less than or equal to
okay,
the,
so ito ay less than or
term.
equal sa A minus N. Tama ba? Yeah.
Yes.
Kasi, okay. Kasi, yeah, tama. Mukhang tama naman siya, no? Kasi yung little n, mas malaki sa big N. Parang mali yung pagkakagamit natin ng big at saka small n, no? So si little n, mas malaki sa capital N. So yung A little n ay mas malaki sa A capital N. So ibig sabihin ito, nagma-minus ako ng mas maliit, ito nagma-minus ako ng mas malaki from the same quantity A, making this guy larger than A minus A little n. Okay? And this will be true for all n greater than or equal to n. And then the reason is since the sequence AN is increasing. Okay? So that means ang A minus A little n ay mas maliit sa epsilon kasi ito ay less than or equal to dito. Pero ito ay mas maliit strictly sa epsilon. So it follows that this guy is smaller strictly than epsilon, right? That's how we got here. And this is true whenever n is greater than or equal to capital N. Okay. And then, ano po masasabi ko rito? I can also say that this is, A minus AN is positive. Is actually, it's not negative. Kasi ang A ang supremum. ang A ay isang least upper bound. Ibig sabihin ito ay mas malaki or equal to sa lahat ng A sub-n's. So alam ko itong difference na to ay non-negative. So this is less than 0. That is greater than or equal to 0. Right? Pero si epsilon ay positive, so si negative epsilon ay negative. So pwede kong ilugsong yung negative epsilon dun sa pinakakaliwa ng inequality. So in summary here, what we have seen is that epsilon or negative epsilon is less than A minus A sub n, less than epsilon. By definition of a continued inequality, we can write it in a more compact way, A minus A sub n less than epsilon. Tapos pwede kong pagbaligtarin yung nasa loob kasi nasa loob naman sila ng absolute value. So I can write this as an minus a inside an absolute value is less than epsilon. And let's review what we have shown here. If you're given an arbitrary epsilon greater than 0, so everything here works for all epsilon greater than 0, we have found a capital N in N such that whenever little n is greater than or equal to capital N, then this inequality is true. And that should sound familiar because that's the very definition of a convergence sequence or convergence of the sequence AN to A. And so that ends the proof. Or actually, that ends half of the proof. Okay? Kasi napakita ko na siya kapag ka-increasing at bounded, automatic convergent. And actually, the proof gave us another insight that is not mentioned in the theorem. Kung pala siya ay increasing at bounded, ano yung additional info? Anyone? Ano yung nakita natin sa proof? Aside from just knowing that MCT is true. Ano pa yung insight na nadagdag niya? Ang sabi lang ng theorem, kapag ka bounded at saka monotonic, automatic siya ay convergent. Pero the theorem gave us another info, another vital information. And what is that? Anyone na hindi pa nagre-recite? Guys, sayang yung points. Baka mahirap yung problem set, sige kayo. So sayang yung mga maiipon yung points from recitation. Anyone? Ano yung added bonus na nakuha natin sa proof? Sirit na? Okay, so the proof, okay, yeah, Ray.
Hello po. Not sure po ako pero try ko lang po na yung limit po nung sequence AN as nag-increase po ay yung A.
Okay, and what is A? Ano nga si A?
Yung supremum po.
Okay, great. That's perfect. Thank you, Ray. Ang additional info na nakuha natin dito, kapag ka pala monotonic yung sequence or monotonic increasing yung sequence at bounded, automatic magko-converge siya by MCT. Pero the proof of the MCT gave us what the limit is. Binigay niya sa atin yung limit pala ay yung supremum. And this will always happen if our sequence is increasing and bounded. Okay, so yun yung added info. So what could be the nice attack if decreasing naman yung sequence? Kasi na-prove na natin na siya ay natotoo yung theorem kapag ka monotonic increasing. Paano kaya pag monotonic decreasing? Can somebody share their thoughts? Ano kaya yung outline ng proof? Ano yung sketch ng proof para sa decreasing sequences? Ano yung big claim? Oh guys, huwag na kayo mahiya. Anyone? Sayang yung bonus. Walang mag-attempt. Going once, going twice, going thrice, time's up. Siyempre, kung decreasing yung sequence, ang i-claim nyo naman, magko-converge siya dun sa infimum. Alright? Kasi decreasing siya at bounded. So, ibig sabihin, meron siyang lower bound. And then, by the corollary to the least upper bound property, kapag ka meron kang non-empty set of real numbers na bounded below, lagi yung may infimum o may greatest lower bound. And your claim would be that infimum would be the limit of the sequence. And you will go through the same process as what we have discussed here. Medyo mababali nga lang yung ibang inequality kasi pwede ka mag-multiply yan ng negative factor. Pero I hope you see the idea, ganun din yung mangyayari. So I hope kung mabigla kayo bukas sa problem set, baka yun yung isang tanong, ipa-translate lang to para sa infimum, then you should be able to give me a good answer. Kaya ba? Baka lang naman. Hindi ko naman sinabi na yun yung tanong sa problem set. Okay? Sinama siya sa remark here in the work text, but I will insert it in the final version of the module as part of the theorem. Itatask ko siya dito, hindi lang as a remark. Alright? Kasi mahalaga siyang parte ng proof. Kasi yung MCT, hindi nagmamatter kung increasing or decreasing. It will work for both. So, hindi kailangan ng separate remark for the decreasing case. All right? So, you have your example 6. Kung paano mag-prove na convergent ang isang sequence even without knowing, or actually, yeah, pwede mong masabi na convergent ang isang sequence without knowing what the limit is. All right, so pwede ko itong gawin yung kalahati ng example 6. Ipakita na yung sequence ng mga a to the power 1 over n ay magko-converge to some number. Tapos bonus na lang na nalaman ko magko-converge siya kay 1. Pero I can use the monotone convergence theorem in order to prove that the sequence 1 over n will converge. And probably we can do that here. Okay. Pwede ko siguro siyang gawin dito. Ito na lang submargin. Oops. Maliit pala yung margin ng handout natin. Pero anyway, paano natin mapapakita na yung a to the 1 over n ay convergent? Okay? Without regards to the limit first. So una, kailangan kong ipakita na siya ay increasing or decreasing. Alright? So start ako sa PA. Kung paano ko siya mapapakita na increasing or decreasing. Now, ano sa tingin niyo to? Increasing or decreasing? So, intuitively, if you will just look at the expression for the nth term, a to the 1 over n, pero provided that a is greater than 1, habang lumalaki si n, yung 1 over n ay lumiliit. Tapos, meron kang base greater than 1, ni-raise mo sa mas maliit na exponent, yung value niya mas liliit. So my claim here, or my hunch, is that this is decreasing. Paano ko siya mapapakita na decreasing? Pero hula ko na siya ay decreasing. So pwede ako mag-start sa PA and then I'm gonna work backwards. Alright? So alam ko na siya ay decreasing. That's my idea. So I can look at a to the 1 over n. Ito yung gusto ko mapakita. Ang a to the 1 over n dapat ay greater than or equal to sa a to the 1 over n plus 1. Right? Ito yung definition ng pagiging decreasing. And again, intuitively, it makes sense. Pero hindi sufficient na sabihin nyo lang, obviously, it is decreasing. So kailangan nyo magbigay sa akin ng analytic proof kung bakit siya decreasing. Alright? So gagawa muna ako ng PA para malaman ko paano yung atake dun sa proof ng pagiging decreasing niya. Okay? Now, this is what I want to show. This is a PA. So it's valid if I go backwards, pero if and only if statements yung gagawin ko. So what I'll do is to raise both sides to the power n times n plus 1. Okay? So ang gagawin ko lang, ito, i-raise ko to sa n times n plus 1. Ito, i-raise ko rin sa n times n plus 1. Okay? So pag ni-raise ko siya sa n to the n plus 1, yung left side, ma-cancel yung n, matitira ay a to the power n plus 1. And this one, matitira ay n to the power n. All right? And then parehas yung base. So that means n plus 1 is greater than or equal to n, which we know to be true. This is a tautology. But here provided that a is greater than 1. Kapag ka si a ay greater than 1, kapag ka mas malaki yung power of the same base, ibig sabihin mas malaki yung exponent niya. So we know that n plus 1 is greater than or equal to n, which is obviously true, right? Isa yung tautology. So that means we can start here. You can say, oh, obviously, n plus 1 is greater than or equal to n. But from that, what we have in the PA are biconditional statements. So I can go from here and say that this will be true. And then I'll go from here until here, and I'll say that is true until I get here. And that will be sufficient proof that the sequence a to the 1 over n is decreasing. And that's what you will see here in the proof or the answer to the example. Yun yung sinasabi ng phrases na to. Okay? Nanggaling lang siya dun sa PA. Pero mas maganda kung isasama nyo, hindi nyo naman kailangang isama yung PA, pero mas okay na gumawa kayo ng PA para alam nyo kung paano isusulat yung proof. Okay? And then, so, tapos na yung pagiging monotonic. Napakita na natin na siya ay decreasing. The next requirement of the monotone convergence theorem is for it to be bounded. Okay? Now, what we see here is that si a ay greater than 1. So, ibig sabihin yung a to the power 1 over n ay greater than 1. Okay? So, ibig sabihin, meron tayong decreasing sequence na bounded below by 1. Kapag meron kang decreasing sequence that is bounded below by 1, so by the monotone convergence theorem, the limit exists. The limit L will exist. Right? So pag hindi naman, pag ang pinapaprove lang naman ay existence ng limit o pagiging convergent ng sequence, then we don't need to find the limit. Pero dun sa example, sinabi na ang limit niya ay 1. So paano natin mahanap yung limit, yung value ng limit? I guess this example used the squeeze theorem. Okay, ginamit niya tong identity na to. Okay, that is true. Pero what can we say? Look at the base here. The base is a to the 1 over n. And this is a 1 over 2 to the n. But this is a subsequence of a to the 1 over n. Hindi na pala gumamit ng squeeze theorem. Pagkakaroon lang ng subsequence. Remember from last time, kapag ka meron kang sequence na involving n, kapag ka pinili mo lang yung mga n's to be even, to be the even integers, then you will have a subsequence. Tapos, alam natin convergent yung a to the 1 over n. So, by the theorem that we have from last time, kapag ka nagko-converge yung original sequence, yung subsequences niya ay convergent din at magko-converge din dun sa same limit. So that means this guy, or the subsequence, has the same limit L as the original sequence. Alright? Pero ito ang sequence, ang limit niya ay L, right? Tapos remember one of the algebraic limit theorems? Kapag ka meron kang limit ng product ng dalawang sequences, so you can think of this sequence to be this subsequence times itself. So ibig sabihin yung limit niya ay product lang ng mga limits. So ang limit nito ay equal sa square ng limit ng a to the 1 over 2n. So the limit of this guy would be L squared. Okay? And then from above, we let the limit of a to the 1 over n to be L. So meron ka nito. So that means L squared is equal to L. Alright? Now, we now know that the limit L satisfies L squared equals L. But the equation L squared equals L only has two solutions, either L equals 0 or L equals 1. Pero dahil yung sequence ay bounded below by 1, ibig sabihin alam natin sa infimum siya mag-converge. Pero si 0 at saka si 1, parehas lower bounds. Pero ang pinakamalaking lower bound actually would be 1 kasi mas malaki siya kay 0. So that means the limit is indeed equal to 1. Okay? Is that clear? Medyo maraming nangyari dun sa example, no? But I hope you did follow. Okay, any questions? Let me think. Or do you want one more example? Paggamit ng least upper bound ng monotone convergence theorem. Okay, maybe let's look at one more example. Yung medyo homework material. Right, so dagdag lang ako ng page. Okay, tingnan natin dito. Halimbawa, i-consider natin itong sequence na to. Sequence ng mga ANs ng itsura ay sum ng starting from k equals 1 until n ng, let's say, 1 over k 2 to the k, where n is a natural number. So ito yung sequence natin halimbawa. Let's call this sequence A, the sequence big A, right? So if you want to list the first few terms of the sequence, so magpa-plug in ka lang. So first few terms of the sequence are when n is equal to 1. So meron lang tayong sum from k equals 1 to 1 ng 1 over k 2 to the power k. So equal lang to sa 1/2. Okay? When n is equal to 2, sum lang siya ng k equals 1 until 2 ng 1 over k to the k ng 1/2. Ito yung nangyayari kapag si k ay 1. Pag si k ay 2, magkakaroon na tayo ng what? 2 times, that would be 2 times 2 squared. So that's going to be 8. Okay. And so this will be 5 over 8. Ito yung next element nung sequence. When n is equal to 3, I'll just copy this guy. Papalitan ko lang yung upper limit ng summation by 3. Tapos yung expansion niya magiging 1/2 plus 1/8 plus the case when k is equal to 3. Okay? When k is equal to 3, we'll have 1 over 3 times 2 cubed. Tama ba? Yes. And 2 cubed is 8, so the denominator here is 24. So basically, this guy would be around 2/3. Okay? And so on. Okay? So nangyayari lang ay 1/2, tapos 1/2 plus 1/8, tapos kinopya ko to, nagdagdag lang ako ng 1 over 24. Okay? So is this clear? Kamukha to nung nakita nyo sa homework number 1. So I hope you guys will not be confused with the notations anymore. Okay. And now we want to show that this converges. So show that the sequence AN converges. And the problem is not asking saan siya nagko-converge. Pakita lang daw natin na siya ay convergent. Okay? And here, I think we can use the MCT para ipakita na siya ay convergent. Number 1, we need to argue yung pagiging monotonic niya. So I'll just sketch the solution. So kayo na yung bahalang magdagdag ng mga magsulat ng sasabihin ko in words. The first one is notice that the sequence is increasing because a sub n plus 1 is a sub n plus some number, say r, where r is greater than or equal to 0. Gusto kong sabihin dito ay na-derive natin yung pang n plus 1 na element ng sequence by adding a positive number or a non-negative number to a sub n. Kung mapapansin nyo, yun yung pattern. Para makuha si a sub 2, kinopya ko si a sub 1, nagdagdag ako ng positive number. Para makuha si a sub 3, ito si a sub 2, remember? Nagdagdag lang ako ng positive number to get the next value. And you know what will happen when n is equal to 4? Copyin nyo lang si a3, tapos dagdagan nyo lang siya ng 1 over 4 times 2 to the 4. That will give you the fourth element in the list. So it's quite clear that to get the n plus 1 element of the sequence, I will just add actually a positive number to a sub n. And that is enough to conclude that a sub n is increasing. Okay? Now, mapapakita ba natin na siya ay bounded? So tapos na yung pagiging increasing. So let's show boundedness. Pero for boundedness, I need to recall this result. Natatandaan niyo pa ba yung formula para sa sum ng geometric sum ng geometric terms? Let me see if I have that written somewhere here. So matatandaan niyo ang sum ng a to the r to the anong gamitin ko? To the k going from 1 to n are actually start ba siya ng 0? Yeah. I think start siya ng 0 ay equal kay a times 1 minus r to the n plus 1 over 1 minus r. Okay. Ito yung sum ng isang geometric list of number geometric sum. Okay. Hold on guys, double check ko lang yung formula ko. Okay, I think this is right. Okay. So ito yung geometric sum, or kung nagsisimula ka kay 1, kasi nagsimula kay 1 yung mga a sub n's natin, magiging a to the rk, ito ay magiging a minus a times 1 minus r to the n plus 1 over 1 minus r. Kasi binawas lang natin yung corresponding summand kapag si k ay 0, which is a to the r to the 0 or a times r to the 0, which will become a. All right? So ito yung sum niya. Then why do I want to see this? Well, because note, that a sub n for any n, right? So note that for any n, yung a sub n, which is the sum from k from 1 to n, ng 1 over k times 2 to the k, will be less than or equal to the sum starting from k equals 1 until n of 1 over 2 to the k. Agree? Kasi ngayon, ang ginawa natin, tinanggal natin yung k. So yung pagtatanggal ng k made the denominator smaller. All right? And the smaller the denominator is, the bigger the fraction is. All right? That's why lahat ng terms dito ay mas malaki sa kapartner niya na term dun sa summation sa kanan. So ibig sabihin itong summation, term sa kaliwa. So itong summation sa kanan ay mas malaki dun sa summation sa kaliwa. Right? Kasi bawat laman ng summation na to ay mas malaki kaysa sa laman ng summation na to. Alright? But this is a geometric sum where what? Where a is equal to 1 and r equals 1/2. Okay? So that means this sum is equal to 1 minus 1 minus 1/2 over 1 minus 1/2. Okay? And this is a constant number? Tama ba? Parang mali. Sorry. Ito ay to the n plus 1. Ito ay n plus 1. Wala na siyang n plus 1. Okay, so ito yung sum Di pala siya constant kasi nag-involve pa siya ng n dito, right? Pero we know that this guy will be less than 1 minus 1 over 1 minus 1 half. Kasi gusto ko makahanap ng upper bound para sa kanya. So pag tinanggal ko itong subtrahend na to, I am guaranteed to get a bigger number. So pag binura ko lang to, mas malaking number na makukuha ko kasi tinanggal ko yung mina-minus ko. And that relieves us of our problem of having the n inside our expression. So basically here we have shown that this is 1 minus what? 1 half. Bakit magiging 2? May mali ba dun sa formula ko? Hold on. Double check ko yung formula. Tama pa ba mga pinagagawa ko, guys? 1 minus. So dapat 1 minus n plus 1. Aha. Bakit siya naging less than negative? Magiging less than negative 1. Parang mali yung kinuha kong bound. Aha. Hold on. Nakita niyo ba yung mali? Okay, let me see. Tama ba yung formula ko? Yes. 1 minus r to the n plus 1. So, maging 1 minus 1 half to the n plus 1 over 1 minus 1 half. So, magiging less than siya doon. So that's going to be 1 minus okay. So I can simply say this is less than 1 for sure. Pero duda ko, bakit naging less than negative 1 siya? Aha. Oh yes, Carlo.
Sir, bakit 1 minus?
What do you mean dito? Oops. Siya yung formula. Oh yeah, thank you. Dapat ito ay sorry, mali yung formula ko dito. Thank you. Dapat ito ay minus a. All right. Thank you, Carlo. Yeah, tama. Dun sa summation ko from 1 to n ng a to the r k, a times r to the k, tinanggal ko yung term para sa k equals 0. So kailangan i-minus ko mula sa kanya yung corresponding to k equals 0, which is a to the r to the 0, which is a. So dapat nandun, minus a, hindi a minus. So yeah. So dapat pala dito ay ganito. Minus 1, and I will get a bigger number if I will ignore the subtrahend in the numerator. So I'll just have 1 over 2 minus 1, and this is equal to sorry, bakit 1 half? This would be 2 minus 1 equal k1. Okay? Kasi magiging 1 half yung denominator, 1 yung numerator. So we'll have 2 minus 1 equal to 1. So what we have shown here is that a sub n is always less than 1. So we have met the two conditions of the monotone convergence theorem. Si a sub n ay increasing at saka si a sub n ay bounded above. And so by MCT, we can say that the sequence is convergent without even knowing kung saan siya nagko-converge. Ang alam natin, nagko-converge lang siya to some number. And in this case, it converges. Nagko-converge lang siya sa isang number. Hindi natin alam kung saan. Alright? Is that clear? Medyo nalito ako dun sa inequality, saka dun sa formulas. Kaya I hate memorizing formulas kasi mahina ako sa uluhan. So, mas okay kung dinerive natin tong summation na to. Pero yeah. So, kung mapapansin nyo, siguro parang ganito, yung magiging homework number 4. Kung may gagamitin kayong result na hindi naman natin approve sa klase, tapos feeling nyo naman ay hindi gumagamit ng 155 concepts katulad nito, pwede nyo na lang siyang sabihing recall. Right? Sabihin nyo lang yung result na ginamit nyo, especially if it was not given in class. Pero be careful, dapat yung result na gagamitin nyo ay hindi something na involve ang 155. Okay? Alright. So if there are no questions there, so let's go to the next big theorem next to MCT. Siya naman yung nested interval property. Okay. Puntahan natin siya sa baba. Okay. So tingnan natin yung sinasabi ng nested interval property. But by the way, the NIP or nested interval property is another equivalent form of the completeness axiom, right? So talagang magkaka-equivalent itong mga statements na to. Ano yung requirement ng nested interval property? So we should have two sequences, ANs and BNs, such that the following conditions are satisfied. Number 1, AN is less than or equal to BN for all N in N. And then number 2, ito na kung bakit siya tinawag na nested interval. Nested interval, ibig sabihin interval sa loob ng interval, sa loob ng interval, sa loob ng interval. Kasi ang kailangan, i-form down natin yung I sub n to be the closed interval AN to BN. Okay? Tapos, dapat superset siya ng I sub n plus 1. So meaning yung AN, BN, ay dapat superset ng A sub n plus 1, comma B sub n plus 1. And this should be true for all n. Kaya siya tinawag na nesting intervals. Yung interval na n plus 1 ay nasa loob ng interval n. So graphically, it will look like this. So yung interval I1 natin ay ito. A1 until B1. Yung interval I2 natin ay itong orange. From A2 hanggang B2. And then yung interval I3 natin, interval from A3 papuntang B3. And you see that I1 is a superset of I2. I2 is a superset of I1. A3 is a superset, sabi ko. I1 is a superset of I2. I2 is a superset of I3. Therefore, I1 is a superset of I3 and so on. So nasa loob, papasok tayo ng papasok dun sa loob ng intervals. Alright? Now, if we have these nested intervals, then ang intersection nung mga intervals na yon, there would be infinitely many of them because we have sequence infinitely many ANs and infinitely many BNs, all right? So ang intersection ng infinitely many intervals IN ay non-empty. Ibig sabihin, lagi siyang magkakalaman. And true enough, if we look at this illustration over here, nasan yung intersection ng mga INs? Makikita natin yung intersection ng mga INs ay mukhang ito. Yung maliit na portion na ito. Alright? And then there's an additional result. Kapag daw nagkataon na yung limit ng BN minus AN ay equal kay 0. But how can we interpret BN minus AN? We can interpret BN minus AN to be the length of the nth subinterval. Right? So yung AN, BN, ang haba niya ay BN minus AN. Pag kinuha pala natin yung sequence form by the lengths of the nested intervals at nag-approach siya kay 0, then yung intersection nung mga intervals na yon ay isa lamang singleton. Isa lang yung laman niya. Ang laman niya si A, pero si A yung limit ng AN at limit din ni BN. Right? So, yun yung gusto natin ngayong ipakita. Kapag meron kang nested intervals, yung intersection ng mga nested intervals na yon ay non-empty. Tapos pag nagkataon na kapag habang lumalaki si N, paliit ng paliit yung length ng subintervals to the point that in the long run, it will go indefinitely close to 0, then isa lamang yung laman nung intersection na yun. Okay? So, clear ba yung idea ng NIP? At least yung drawing. Or is anything not making sense? Oh, guys, react naman kayo. Ayaw talaga? Okay, maybe the proof will give us an idea of paano nag-work tong nested interval property. So let's try to write the proof of the NIP. Tapos siguro gagamitin ko rito ay maybe I can make use of the Monotone Convergence Theorem para mapakita na non-empty yung intersection nila. Okay? So here are our assumptions. Suppose that ANs and BNs are sequences such that AN is less than or equal to BN for all N in N. And IN, which is defined to be AN until BN, is a superset of I sub N plus 1, which is defined to be A sub N plus 1, comma B sub N plus 1. Okay? Now, siguro pwede kong gamitin yung idea dun sa illustration. Balikan natin yung illustration. Ano yung intersection ng mga I sub N's? Kung mapapansin nyo, ito yung intersection niya. Tapos parang ito ay based dun sa suggestion ng illustration. Nandito siya sa A at nandito siya sa B. Tapos ano sa tingin nyo si A at saka si B? It seems that A and B are the limits of the ANs and the BNs respectively. Kasi ang alam lang natin, nested yung interval. So intuitively, dahil nested yung interval, dapat increasing yung mga AIs. Kasi dapat yung A sub N ay subset, ay yung IN, dapat superset ng I sub N plus 1. Okay? So this means, so the nesting of the intervals suggests the following. Dahil dapat yung A sub N, dapat yung IN ay superset ni A sub N plus 1. So dapat si IN nasa loob, si I sub N plus 1 dapat nasa loob ni AN to BN. So dapat si A sub N plus 1 at saka si B sub N plus 1. Ganito yung itsura. So that makes A sub N smaller than A sub N plus 1 para matuloy yung nesting ng intervals, right? So that means it suggests A sub N is less than or equal to A sub N plus 1 and B sub N must be smaller. Hold on, tama ba? Ang AN dapat mas malaki, mas maliit sa A sub N plus 1. Yeah, I think this is correct. Sa BN naman, yung B sub N, dapat ay mas malaki or equal to sa B sub N plus 1. Okay? Right? So that for all N in N, that is the ANs and BNs are monotonic. Okay? Moreover, I can say that Same property. Dapat dapat ang I1 ay superset ng IN for all n in n. So that means ang AN dapat less than or equal kay B1 for all n in n. Agree? Bakit dapat totoo to? Ang A sub n dapat mas maliit or equal kay B sub 1. Agree ba kayo dyan? Ang A sub n ay dapat mas maliit kay B sub 1. Kung hindi nyo ma-envision, balik kayo dun sa drawing. Okay, ito yung A1, ito yung A2, ito yung A3, tapos nandito si B1. Kasi dapat superset ng lahat ng interval si I1. So, ibig sabihin, hindi pwedeng lumampas yung right bounds ng mga INs kesa kay B1. That makes Bn less than or equal to B1, but each of the Bn's is less than or is greater than the ANs. So that makes all ANs less than B1. Okay? And similarly, yung A1 ay mas maliit sa lahat ng Bn's for all n in n. So in essence, what we are saying here is that the ANs are monotonic, the sequence AN and the sequence BN are monotonic. And at the same time, the sequence AN is bounded above, the sequence BN is bounded below by A1. So therefore, by MCT, okay, AN converges to A in R, and BN converges to B in R. Okay? So nagko-converge sila dapat kasi monotonic sila at saka bounded. So that means dapat nag-exist yung limits nila. Hindi natin alam exactly kung sino, pero tawagin natin silang A and B to coincide with the A and B shown in our figure. All right? Then what else do we know about this, guys? Actually, pwede pala nating sabihin, aside from convergence to just generic values of A and B, dahil increasing sila and decreasing, we can say that A is the supremum of ANs, and B is the infimum of the BNs, right? So, if X is on the closed interval AB, then what can we say? Then X is between A and B. Okay? Tapos dahil si B ang infimum ng mga BNs, so this guy will be less than or equal to BN. And then dahil si tama. Tapos si A ang least upper bound ng mga ANs. So ibig sabihin lahat ng AN ay less than or equal to A. Right? And this is true for all n in n. So what are we saying here? Kapag ka merong X na element ni AB or kapag ka si X element ng AB, then si X ay between A sub n and B sub n for all n in n. So that makes X an element of IN for all n. Nasa loob siya ng lahat ng mga nested intervals. Kasi nasa pagitan siya ni AN at saka ni BN for all of the n's, for all natural number n. Right? And this is guaranteed to exist kasi nag-exist yung A, nag-exist si B. So ibig sabihin, merong closed interval AB at meron niyang at least isang laman. Kung ang laman niya ay si X, yung X na yon ay nasa lahat ng intervals. So that makes X an element of the intersection of all of the INs. All right, making the intersection of the INs not empty. Kasi meron siyang laman. Laman niya, lahat ng laman ng closed interval AB, where A is the limit of AN and B is the limit of the BNs. All right? So I guess we're 80% done dun sa proof. Kailangan na lang nating i-prove yung moreover. So ang assumption sa moreover, dun sa second part ng conclusion, if the limit of the limit of BN minus AN is equal to 0, then we want to show na isa lang yung laman ng intersection. All right? But if this is true, then that means B minus A is equal to 0. Okay? Kasi from the algebraic limit theorems, alam natin nagko-converge yung Bn minus An. Tapos alam din natin ang limit ni Bn ay si B, limit ni An ay si A. So ibig sabihin yung limit ng Bn minus An ay equal sa B minus A. Pero sabi natin yung limit ng Bn minus An must be equal to 0. So that means B minus A must be equal to 0. But that is the same as saying B is equal to A. And thus, the closed interval AB reduces to this closed interval, which is basically a singleton. Isa lamang yung laman niya, which is the number A. And this completes the proof. Kasi sinabi na natin na si A, siya yung supremum ng mga A sub n's. Okay? Or you can alternatively say siya equal siya kay B, where B is the infimum of the BNs. Pero equal lang naman sila. So ibig sabihin, nagmi-meet yung supremum ng mga ANs at supremum ng mga BNs. So ibig sabihin lang, kung babalikan natin yung drawing natin kanina ng mga nested interval, ibig sabihin, hindi pala to si A, hindi to si B, pero ito lang siya, A equals B. So yung intersection ng lahat ng mga nested interval ay isang point lamang kung ang limit ng lengths ng mga nested intervals ay nag-approach sa 0. Okay? And I think that completes the proof. Okay. In the work text, there are some illustrations of the nested interval property. Kindly take a look at them. Tapos i-discuss natin sila next meeting. All right? Parang dadalawang theorem yung diniscuss natin today, pero parang ang daming nangyari, no? Nag-stuck kasi ako dun sa formula ng geometric sum. Sorry about that. Yeah, namali yung formula ko sa isip. Pero thank you for pointing out the error in that. But aside from that, do you guys have some questions? So in summary, meron na tayong collection ng mga possible completeness actions. Meron tayong dedicants, meron tayong LUB property. Tapos ngayon nakilala natin yung Monotone Convergence Theorem. Tapos mapapansin nyo ang major building block ng proof ng MCT ay LUB property, existence ng supremum, okay? Or existence ng infimum. And then now we have the nested interval property, and you see that the main ingredient for the proof of the nested interval property is the monotone convergence theorem. And actually, you can form a circle or a cycle within these statements para ma-prove na sila equivalent sa isa't isa. Okay? And then next week, we'll look at some more equivalent statements to this guys, namely Bolzano-Weierstrass theorem. And then we'll have the Cauchy convergence criterion. And I think we'll end up with the Heine-Borel theorem. So yun, medyo tatlo pa ito. And then that ends unit 2. So hopefully matapos natin to next week. If not, then ikakat ko na lang yung coverage ng problem set for unit 2 kung hindi natin matapos si Heine-Borel. Okay? Any questions? Other concerns? Okay, so if there are none, then yung mga nag-recite, pa-comment naman sa chat box. na nag-recite kayo para ma-note ko yung additional points niya sa problem set. Carla, member ka na ba ng Teams? Or hindi pa? I-comment
Hindi pa,
ko na
sir.
lang kung
Yung
in case
office
na-
kasi.
Sige.
Office kasi.
Iba yung account na kailangan mo dito no? So, request ka na lang sa ITC. Pero comment ko na yung pangalan mo rito. The others who are members of the team, please put a comment in the chat box para dito ko na lang hahanapin yung bonus. Itatali ko siya. Tapos makikita nyo sa problem set kung ilan yung bonus nyo. Alright? Okay, other concerns? Kung wala naman, then thank you guys for joining me today, and then enjoy your weekend, and let's see each other on Tuesday, right? And hopefully, don't forget, bukas ay available na yung problem set. Okay? Bye, guys.
Thank you.